Hello, my wonderful students. You're welcome to class again. Now, today we want to continue from where we stopped the last time. So, the last time we looked at some questions under set theory, where we looked at complement of a set, intersection of sets, and union of a set, and also we looked at number of elements in a set. I want to believe you still remember what we did the last time. So if you don't have opportunity of watching the last class, you can go back and check for it. All right, now today we are going to be looking at set builder. Sets builder. All right, now let's look at it. And let's look at the example we have here. Now, list members of sets A, B, and C. List members of set A, B, and C. Now, look at the first set we have here. Okay, now set A is the set of x such that x is less than 4, where x is a natural number. All right, okay, so I'm going to explain what I've just said now. So please inform your friends that the class has started. All right, now okay, I want to check. I'm only seeing one person here. All right, so you can invite your friends, let them know that the class has started. Make sure you share the link with your friends. Okay, now let's go on. Now, look at what we have here. A is the set of, I told you how to read a set. Now, A is the set of, that is the meaning of what we have here. A is equals to set of, this curly bracket means set of. So A is the set of x, such that, this column means such that, now x is less than 4. That is, the values of x that are member of this set, they are less than 4. And honestly, if you think of it, you will see that we have uncountable and different forms of numbers that are less than 4. We have decimal numbers that are less than 4. We have negative numbers, we have positive numbers, we have fractions that are also less than 4. All right, but when you look at what we have here, now this condition here is making a definition, a specific definition, that set of values of x are natural numbers. So the number they are talking about here, they are natural numbers. That means that they are not decimal numbers. All right, they are not decimal numbers. That's the reason why we have this condition. Now, x is contained in natural number. Now, in this case now, n represents set of natural numbers. Okay, all right. So now we have to list natural numbers that are less than 4. So that is what we want to do now. So let's list. Okay, natural numbers less than 4. Hope you remember the definition of natural numbers. Now, I told you that natural numbers are what? Are counting numbers. Okay, can you tell me what are the natural numbers that are less than 4? So now, I want you to drop your answer in the comment section. Let me see what you have if you remember what we did the last time. So, natural numbers less than 4. Okay, let me see what you have. Okay, natural number less than 4. Is there anybody dropping any answer? Natural numbers less than 4. Natural number less than 4. Anyone? Okay, I've not seen anyone yet. Okay, natural number less than 4. Okay, don't forget, I said that natural numbers are counting numbers. So they are 1, 2, 3, 4, 5. So the one you're going to list among all these, they are the ones that are less than 4. So they are 1, 2, 3. So you are not going to list 4, because natural numbers that are less than 4 are the one we are listing. So we have the answer to be this. Okay, now let's look at the second one. B. Okay, can we read this set together? Now B. B is the set of x such that, colon means such that x is less than or equals to 4. X is a member of integers. Z denotes integer. This one means integer. So set of integers. Now this set of integers. So x is a member of integer. Alright? So now you remember the definition of integers. I said integers are what? Are whole numbers. Integers are whole numbers. Alright, so an x is a subset or is an element in a set of integers. So now let us list values of x that are less than or equals to 4. And they are also what? Integer. So now let's list. Now the biggest is going to be 4. So we have 4, followed by what? We have 3, we have 2, we have 1, we have 0, we have -1, and so on. You understand? All of these numbers now listed, they are all whole number. Alright? They are all whole number. They are all whole numbers. And as you can see, all of these are also less than or equals to 4. Unlike this. Now can you see the difference between set A and set B? Set A is a set of natural numbers strictly less than 4. All of these are strictly less than 4. Now look at this second set. Set B is the set of x such that x is less than, not only less than, and also equals to 4. That is why 4 is inclusive. And this time around, x is a member of what? Integers. So that means 0 is inclusive, -1, -2, -3, and so on. So it's going to be a finite set. That is, the set is uncountable. Right? Okay, now let's look at the third one. Look at the third one. Now C is the set of x such that -2 is less than x and x is less than or equals to 3, where x is a member of natural number. Alright, now let's look at it. Now we have -2 less than x less than or equals to 3. Now let us first assume that the values of x are whole numbers. You see, the values you are supposed to list here now, -2 must be less than the value you are going to list. Okay, and also the values you are going to list here must also be less than or equals to what? 3. So now let's look at the space of number. So we have -1. -2 is less than -1. Alright, if you are having a depth of 2 and somebody is having a depth of 1, so the person that is having a depth of 1 is better than someone having a depth of 2. Alright, so -1 is more than what? More than -2. So, and we said -2 must be less to the values we are going to list. So -2 is less than -1, is also less to 0, is also less to 1, is also less to 2, also less to what? 3. But mind you, we must not go beyond 3 here because x is less than or equals to 3. All of these are less than or equals to 3. Alright? They are all less than 3 and 1 is also equals to 3. Okay, so now you can see. But look at the condition we have here. X is a member of natural number. So that means this is not inclusive because this is not a natural number. It's not a counting number. This one too is not also a counting number. So that means this set of number is going to be 1, 2, 3. So we have 1, 2, 3. Okay, you get that? Alright, so that is the solution to that problem. So if you are going to award mark to that, so for listing correctly, we have a block mark 1 for this, block mark 1, and this block 1. So don't forget, for you to get this, you have to put 3 dots. It means that it's infinite. Alright? Okay, so now let's move down to another question. Now, example 2. Example 2. Example 2, given that x is an integer, list the members of x less than 4 intersection set of x so that x is greater than or equals to -2. Okay? All right. Now let's look at this question. Given that x is an integer, list the members of this set of x such that x is less than 4 intersection set of x such that x is greater than or equals to 2. Now before we solve this problem, I want you to share this video with your friends. So those people that are not yet here, now inform them the class has started. All right, so let me check those of us that are available now. Okay, good. All right, so inform others. Now let's look at what we have here. Now we want to find the intersection of these two sets. Now the first thing I'm going to do now is to list members of this set and to also list this member, so I'll be able to do the intersection. All right, now let's list member of this set of x such that x is less than 4. Okay, now what is going to be the member of this? Now don't forget, the statement said that x is an integer. So anything I'm going to list here must be an integer. All right, you know what an integer is? Integers are what? Whole numbers. They are whole numbers. All right, now let us list whole numbers that are less than 4. That's the meaning of what we have, a set of whole numbers that are less than what? 4. So now we have 3 because they must be less than 4. So values that are less than 4 and they are whole number. They are 3. We have 2. We have 1. Okay, you have what? 0, you have -1, and so on. Okay, so let's list more. Okay, we also have -2, and so on. Okay, yeah. All right, so this is the set of x such that x is less than 4. Now let us look at the second one. Set of x such that x is greater than or equals to -2. Okay, now let's list this member. Now set of x such that x is greater than or equals to -2. Now we want to list integers that are greater than or equals to what? -2. So let's begin to list numbers or integers that are greater than or equals to -2. So since it is also equals to -2, so we start from -2. Now numbers that are greater than -2, we have -1. We have what again? We have 0. What do we have again? We have 1. Next we have 2. next we have 3, next we have 4, and so on. These are whole numbers. Hope you agree with me. They are integers and they are all greater than -1 and also equals to -2. Okay, now we can now do the operation now, intersection. So we are intersecting this and this. So what is going to be our answer now? We want to intersect this and this. Now I told you the last time, now when you are finding intersection of two sets, now we are looking for those elements that are inside the two sets. So intersection of set A and set B are those elements that are inside set A and they are also inside what? Set B. I come again. Intersection of set A and B are those set of elements that are in set A and are also in what? Set B. So now let's look at those sets. So those sets of members that are in set A and also in set B, if this one is A and this is B. So now you can see -2 is here, -2 is also here. So we have -2, -1, -1. We have -1. We have 0, we have 0 here. Okay, we have 1 and we also have 1 here. 2 and 2, 3 and 3. So we have 4 here, but there's no 4 here. So that means we can't list again. So that is the end. So this is going to be the answer to this problem. So how do we award mark to this question? So for listing this correctly, there will be a block mark for that. For this as well, a block mark. And for doing the operation, we have M1. And for getting the answer, we have A1. So it's going to be 4 marks question. All right, so this is how we award mark to this type of question. Hope you are learning 1 or 2 things. All right, now I want to move down to a question. A question that is similar to what we just did now. All right. All right, we have if A is the set of 1, 2, 3, 4, we write A using set builder notation. So okay, now this is the question. So how do we solve this problem? All right, how do we solve this problem? Yes. Now A is the set of 1, 2, 3, 4. Now we have to rewrite A using set builder notation. Now the first thing I'm going to do now is to examine these sets. I'll ask myself, what set of numbers are these? What set of numbers are these? Now it depends on the way you are looking at it. Now I can come up and say these are sets of natural numbers. These are set of natural because they are counting numbers. Counting numbers start from 1, 2, 3, 4. You are correct. And somebody can just look at it and say that these are sets of integers. That is also correct. Why? Because integers are whole numbers. You can agree with me that all of these are whole number. Alright, so now that means that there are several ways you can write the set builder notation for this set A. There are several ways. Now let us look at the ways we can use to write this set in set builder notation. Now let's look at the first one. A. Now these are set of natural numbers. You agree with me? So I will say these are sets of x such that all of these numbers now, they are greater than 0, or I say 0 is less to all of these numbers. Do you agree with me? If 0 is less to all of these numbers, so that means set of x such that 0 is less than x. So all of this number now is represented with x now. So if 0 is less to all this, do you agree with that? So set of x such that if 0 is less to x. You get that now? All of these are less to 0. So now all of these now have been represented with x. And also, all these numbers are also less to 5. They are all less than 5. So they are less to 5. So now, where x is a natural number. Okay, you can see? So this one way of writing it, or to write it this way, A is a set of x such that 1 is less than or equals to. Now look at all this number now. 1 is less to all of this, and it's also equals to 1. So I have 1 is less than or equals to x. That is less than or equals to all the numbers we have here. And it's also less than or equals to 4. You get that now? All of these are less than or equals to 4 itself. Alright, so you can write it this way, where x is an integer. You can use integer because they are all integers. So you can use integer or use natural numbers. Okay, now I can also write the set of A this way. It's the set of x such that if 0 is less than x, we said that earlier, if 0 is less than all of this number, and all of this number are less than or equals to 4. Okay, you get that now? So where x is contained in natural number. Okay, we have several ways we can write out this. So now this is the answer to this problem. So now the mark for this is just B2 for getting it. So any of the answer is the correct answer. So that's it. Hope you get that. All right, now let us look at another one just to be sure that we have gotten this. Let's look at another one. I'll just change the values we have here. Let's change the values we have here. Now suppose these numbers are, we have -3, -2, -1, 0. Okay, so I want to write this in set builder notation. Now look at what we have here. We want to write this in set builder notation. How do we do this? Now the first thing, you examine the set of numbers. Now look at this set of numbers. They are all whole numbers, so that means they are all integers. Now, you know they are not natural numbers, unlike the one we did earlier, because natural numbers are counting numbers. As a matter of fact, we don't even have any counting number here. Alright, so these are sets of integers. So now, I can now write A is the set of x, set of integers that are less than -4. All of these are less, they are less to -4. Alright, less than x. Okay, sorry. Now, -4 is less than this. So that is what I wanted to say. -4 is less than all of this. You agree with me? Okay, so -4 is less than x, and the x is less than 1. X is less than 1. All of these are less than 1. Okay, so where x is an integer. Where x is an integer. Now see, another way of writing it, I can write A is the set of x such that -3 is less than or equals to all of these minus 3 is less than all of these, okay, all right, minus 3 is less than or equals to x, less than or equals to 0. They are all less or equals to 0. So where x is contained in integer. All right, so that is that. So that is all about set builder notation. So now let's take note of that. So I'm going to give you a set notation, and you're going to tell me the answer. So you're going to drop the answer in the comment section. All right, now let's try this. Let's try this one. List members of set R, where R is a set of x such that minus 2 is less than x less than or equals to 4. X is contained in natural number. Okay, so now let's quickly do this one in 2 minutes. Let's do this in 2 minutes. Now, list members of set R, where set R is this. Okay, now do this and drop your answer in the comment section. Do this and drop your answer in the comment section. All right, I've not seen anyone drop in here. Okay, I'm checking. I think I can see Anike Hola. I'm waiting for your answer. Folake Shugbamu, I'm also waiting for your answer. Oluwaseun Huba. Okay, I'm waiting for your answer. So it's a very simple one. Okay. All right. While we are doing this one, so ensure you share this video with your friends, those people that you feel they're supposed to be on the platform and they are not here. So share it with your friend. And also, if you have not subscribed to this channel, ensure you subscribe and also tap the like button. All right. So the time is almost out. Yes. Okay, let me check. All right, I can see Balogun. We have 1, 2, 3, 4. Okay, all right. Now let's wait for another answer. Is there anybody dropping? Anyone? Okay, I'm only seeing one person dropping an answer. Yes. Okay. Ashomide Yetunde, I can see you. I can see -2, -1, 0, 1, 3, 4. 1, 3, 4. Okay, let's wait for others before we give the final answer. Okay, I need one more person. Okay. Okay, Bamidele is just joining now. All right. Okay. Okay, your time is up. So by now you should have finished. So now let's look at it. Very simple. Now, the set of R is the set of x such that -2 is less than x. -2 is less than x, and x is less than or equals to 4, where x is natural number. Now, let's look at it now. Okay, so now let me get the numbers that lies within this range. All numbers that lies within this range. Now, I want to list all numbers that are greater than -2. Or I say that -2 is less than them. So we have -1, 0, 1, 2, 3, and 4. Look at all of these numbers. -2 is less than x. -2 is less than all of these. Hope you agree with me. Good. Now, And all of these numbers now, they are also less than 4 and also equals to 4. They are less than 4 and 1 is also equals to 4. So, and this is the space of the numbers. Now, but there is a constraint here, sorry. Now, you are to list only the natural numbers. You have to list only the what? Natural numbers. So now that means all of these now are not inclusive. So this will not be there. So I'll be listing 1, 2, 3, and 4. So this is going to be the answer to that problem. Alright, so if you got the answer, so you can mark yourself. Alright, so that's going to be B1. So that's the answer to the problem. Alright, so now let's move down to something else. Let's move down to something else. Now I want us to look at this question, the past question, why past question? Why past question? Okay, next example. The Venn diagram above. The Venn diagram above represents a universal set calling U of integers. So list the elements. List the elements of the following set. List the elements of the following sets. So the first one, we have P union Q. The second one, P intersection Q. The third one, P union Q complements. Okay, and the last one here, we have P intersection Q complements. Okay, now let's look at the question on the board. Now this is a Venn diagram. Now when you look at it, we have two subsets here. We have sets P and set Q. Alright, we have set P and set Q. They are subsets of the universal set. When I say subset, a set in another set. So they are subset of the universal set calling U. Alright, now if I should ask you now, how many elements are in set P? All you just need to do, just go to the circle of P. This is the circle of P. Count the number of elements. 1, 2, 3, 4, 5. So I ask you to list members of set P. So they are 0, 2, 3, 6, and 7. Now let's list member of set Q. They are 3, 4, 6, and 7. But now if you watch closely, you will discover now that we have two elements that are common to set P and set Q. They are 3 and what? And 7. Okay, so because you can see now that the circle overlapped here. Alright, so now also we have some elements that are inside this universal set, but they are not in set P and set Q. They are 1, 5, 9. Now, suppose you are asked, what are the elements that are in the universal set? What are the elements that are in the universal set? They are one. Now, I'm asking for the element that is inside this box. That's what I'm asking for. All right. So they are 1, 2, 3. Okay, I start from 0. Sorry, it's 0, 1, 2, 3, 4, 5, 6, 7, and 9. All right. So these are members of the set of the universe sets. Okay. So now let's look at this question now. The question asks us to find P union Q. P union Q. That means we write or we list members of P and Q. Members of P and Q, they are the ones we have in this space here. So now the answer to that will be, we have 0, 2, 3, 4, 6. Okay, I think we are supposed to have 8 here and not 6. Okay, so we are supposed to have 8 here. Alright, so please let's take note of that. So now, so we have 6, 7, and 8. Okay, so that's the answer to that problem. Right? Okay, good. Sorry for that break in transmission. Now, look at it. Now, P union Q is the set that we have here is 0, 2, 3, 4, 6, 7, and 8. And we have listed it. That's the answer to that problem. Now, let's look at the second one. P intersection Q. P intersection Q. Now, what's this one asking for? It's asking for those elements that are in set P and are also in set Q. Elements in set P and are also in set Q. So what are the elements? Can you tell me before we do it together? So now let me see. Drop your answer in the comment section. Elements that are in set P and are also in set Q. Right? Element in set P and set Q. P intersection Q. Is anybody giving me the answer? Okay, I can see someone. Yes. Okay, Oluwaseun. I can see Folake Shogbamu. That's good. I can also see Shomide. You are not giving an answer. Okay. Okay, Balogun. We have Bamidele. Yes, I can see Bamidele dropping an answer. All right. Okay. Who is this? Omotola. Yes, Omotola is giving an answer. All right. Okay, thank you. I can see we are all in class. Now, there are 3 and 7. Okay, elements in set P and in set Q. That is common. That is element that is common to this set. They are 3 and 7. So we have 3, 7. So you guys are doing well. I can see your answer. So you have 3, 7. Now let's look at this next one. I want to see those people that will give us the answer to this. Now, P union Q complement. P union Q complement. So let me give you 1 minute to list the elements. So I want to see the set of people that will give me the answer. P union Q complement. Okay, can we try that and let's see. What do you have? P union Q complement. Okay, now let's drop our answer in the comment section. P union Q complement. P union Q complement. Yes, I'm waiting for others to drop the answer. Okay, Bamidele, you have not dropped anything. Shomide and the others. Okay. Yes. P union Q complement. Nobody is dropping an answer. It's a very simple one. It's pretty simple. Okay, who is dropping? Or I'm not seeing anybody here. Okay, P union Q complement. P union Q complement. Okay, since I'm not seeing anybody dropping an answer, all right, now let's do it together. Okay, P union Q complement. Now, the meaning of that, I explained to you the last time. Now, there are those elements that are not in P union Q, but they are in the universal set. If I say complement of a set, there are those elements that are not in that set, but they are in the universal set. Say, for instance, now, Ogun State is a subset of Nigeria. It's a subset of Nigeria, that is a set in Nigeria. So now if I ask you, what is Ogun State complement? There are those members of Nigerians that are not from Ogun State. So those that are not from Ogun State, they are complements of Ogun State because they are in the universal set that contain Ogun State. Alright? So in this case now, P union Q complement. This is P union Q complement. All the elements we have here. Okay, P union P is this. The complements are those ones that are not here. So they are 5, 1, 5, and 9. Hope you get that. Those that are not here but are outside. So that means it's going to be the set of 1, 5, and what? And 9. So that is the answer to that problem. Okay, good. Now with that explanation, I think you should be able to provide this answer. Now, P intersection Q complement. P intersection Q complement. Hope you now know the meaning of complement now. So can you tell me, can you list members of P intersection Q complement? Let me give you a minute to do that. And let's wait for your answers. Let's see those people that will give us the correct answer. Okay. Let's wait. Okay. Yes. All right. Okay. Somebody has given an answer. I can see 1, 2, 4, 5, 6. That is Balogun. Yes, Remilekun. I can see Folake Shubamu. I can also see Oluwatosin. I can see Oluwaseun Huba. Okay. All right. Okay. Good. Yes, now can we do it together? Now let's do it together. Now, P intersection Q complement. Now, the question I ask myself, where is P intersection Q? P intersection Q here. So this is 3 and 7. The complement are those ones that are not here, but they are outside. Those ones that are not here, but they are inside the universal set. So they are. You can start from the list if you like. 2, 1, 2, okay, 6. We have 4, we have 5, and then we have 9 and 8. I think we are not missing anything out. Now let's look at it. 0, 1, 2, 6, 4, 8, and 9. So everything is complete. So now we have 0, 1, 2, 6, 4, 5, 9, 8. Now the order does not really matter when you are listing members. You can see now they are not ordered. You understand? So if you arrange it the other way around, it doesn't change anything. All right. So now the order does not mean anything. So but what must be inside the set must be 0, 1, 2, 4, 5, 6, 8, and 9. So we must see that in the set. So once that one is there, the other is immaterial. Okay, so I can see that some of you got the answer. All right, so that is the answer to that problem. All right, so now before I round off for today, let me give you another question. I'm going to give you another question. So now that's going to be the final one. So we continue from there in the next class, hopefully tomorrow. Okay, now let's look at this. Okay, yes. Now let's look at this problem. Before we do this, yes, if you have not subscribed to this channel, ensure you subscribe and you tap the like button. All right, so don't forget to do that. Now let's look at the question. Now in a class of 40 students, a student can offer French or history or both. Now if 20 offer French, 23 offer history, and 6 offer neither, how many students offer both subjects? All right, now when you look at this question, we need to understand the question now. So they are talking about a class of 40 students. Now, the meaning of that is the number of the universal sets, when you count all the numbers of elements in the universal set, is what? 40. In a class of 40 students. All right? So in the universal set, we have some subsets, some set of students. Now, a student offer history or French or history or both. Now, we have 20 students offer French. So we have some set of students that offer what? French. We have another set of students that offer history. And we have 6 that offer neither. They do not offer neither French nor history. Now the question is, how many students offer both subjects? All right, now let's list all of these one after the other. Now let's say calling U should represent the universal set, okay? And let F be the set of those that offer French. Okay, and H to be the set of those that offer history. Okay. Now, from what we have here now, and we have said that calling you to be the what? The set of all the students. Okay, set of all the students. So if we have that, number of members of sets, don't forget this notation, number of members of set F, that is those that offer French. Now let's look at it from the question now. If 20 offer French, that means number of students that offer French will be what? 20. You get that? Now 23 offer history. Number of those that offer history, age, is 23. Now let's look at it again. Now 6 offer neither. That is, number of F junior H complements. You know this one is neither. They are not in F and they are not also in H. That is, they do not offer French and they do not also offer what? History. How many are they? There are 6. Alright. These 6 students do not offer any of the subject, but they are member of the class. Hope you get that. Good. So now, the total number of the students in the class, let's write that one. Number of the total students, that will be 40. Okay, so now this information now will be displayed on a Venn diagram. So now let us see how do we do that. Now we have it this way. So we have 2 subsets, set of those that offer French and set of those that offer history. So let's say this is French, this circle is for French, and this circle is for history. So the total number of those that offer French, how many? 20. Total number of those that offer history, how many? 23. Okay? Alright. Now, the number of those that offer both subjects, that is what we are looking for. Now, those that offer both subjects, they will be here. Hope you understand now. Those that offer French and also offer history, they will be here. Now, when you look at this region now, there is no French here. So that means this, any student find in this area, they offer history only. Any student find here, offer French only. But any student find here, offer both French and history. So, and that is what we are looking for, we don't know. So we can represent that with X. Alright? Now, so what I need to get now, the number of those that offer French only. How will I know them? Now, just remove those that offer 2 subjects. Remove them from number of those that offer French. Right? The total number of those that offer French, they are what? 20. Alright? So we now have X number that offer French and history. Right? So let me remove those that offer French and history from those that offer French. So I will have only French only. So now I will have 20 minus X. So 20 minus X is the number of those that offer French only. Now, what of the number of those that offer history only? Now, what would that one be? Hope you know. That's going to be 23 minus X. Oh, that's good. That's 23 minus X. Because the total circle here is 23. So if I want to get only this region now, it's going to be 23 minus X. Now, we have some students that did not participate in any of the subjects. They did not offer any of the subjects. So there are how many? 6. 6 of them. So now, when you now look at this, this rectangle we have here is our universal set. So the total number here is going to be what? 40. That is what we have. Total number of students in the class, they are 40. All right. Now, what we have here, we have 4 parts. Part 1, part 2, part 3, and part 4. Now, if you add all these 4 parts together, it must give you 40, because all of these sets are inside the universal sets. You get that now? So now, I will add this and this and this and this together and will equate it to 40. Hope you get that. Those that offer French only, those that offer French and history, those that offer history only, and those that offer neither history nor French. So I'm adding the 4 parts together. Once I add together, it must be equal to 40. So let's do that quickly. So we have 20 minus x plus x plus 23 minus x plus this one, the 4th part, is equal to 40. Hope you get that. This plus this plus this plus this equals to 40. So now, let us add all the numbers together. Now, we had 20 plus 23. That gives you 43. So 43 plus 6, that is 49. So we have 49. And look at this, minus x plus x, that is 0. Okay, so minus x, so that's minus x equals to 40. Okay, so now let's bring 40 here and then bring minus x to this side. So now, so we have, so if you do that, now let's do that up here. So we have 49 minus 40 equals to x. Okay, once this one comes here, the sign changes to negative, and this negative change to positive here. So now 49 minus 40, that is 9 equals to x. So that means x equals to 9 students. 9 students. So the answer to this problem is 9 students offer both subjects. 9 students offer both subjects. So now, how do we award mark to this? Now, for showing all these things correctly, there will be a block mark too for that. For equating this to be 40, we have M1. For solving, M1, and for getting the answer, A1. So what is the total mark? We have 5 marks all together. 5 marks all together. Alright, so that is the answer to this problem. Now, before I leave, I will want you to do this for me. You drop the answer on the comment section. Now, I want you to get the number of those that offer French only. Get the number of those that offer French only. Now, let's quickly do that. Number of those that offer French only. Those that offer French only. Number of those that offer French only. Now, you do that from your Venn diagram. Number of those that offer French only. French only. Okay? Alright, let's wait for your response. Number of those that offer French only. Okay, I'm seeing someone dropping 9. 9. Those that offer only French. Only French. Okay. Those that offer only French. Okay. Yes, I'm waiting for your answer. Okay, let me just get one answer and we'll wrap up the class. Okay, I can see someone dropping an answer. Balogun dropped an answer. 11. Okay, let's see if we can get another person. Okay, number of those that offer French only. French only. Okay, somebody has dropped an answer. I think that is Ogunide. That's 9. Now somebody drop an answer. Anike Ola, that is 10. Somebody drop another answer. Huba, 11. Okay, another person, 10. I can see 10. Okay. Yes. Yes. Any other answer before we leave? Okay. Yes. Oluwatosin. Yes. 9. Number of those that offer French only. Okay. Bamidele, 11. Okay, good. So I think we have all tried. Okay, I can see another one. Show me day 11. Show me day 11. Okay. Shogbamu 11. Shogbamu 11. Okay. Okay, all right. I think we have all tried. Now let us look at it. Number of those that offer French only. Now, number of those that offer French only. Look at it. This is the region of French only. This is the region of French and history. This is the region of history only. So this is number of those that offer French only. That is 20 minus x. Number of those that offer French only. This is only French. Okay, so and don't forget, we have already gotten the value of x to be what? To be 9. So that is going to give you 20 minus 9. And the answer is going to be 11 students. 11 students. So this is going to be the answer. Those of you that got 11, you are correct. And those of you that get 9 or you got 10, so check your workings. So this is what you expected to get. We all try. So now, how do we award mark to this? M1 for writing these statements and the A1 for the answer. All right, I want to believe we have all learned one or two things in today's class, and I'm so happy that you all waited till the end of the class. So tomorrow I'm going to find time, the time we're going to meet. Probably it's going to be 7:30 in Nigerian time. So we're going to continue from where we stopped. Okay, so thank you for watching, and don't forget, those of you that have not subscribed to the channel, you ensure you subscribe and make sure you share this video with your friends. They need to know what is going on. We want the class to go viral. All right, I appreciate everyone. Thank you very much. Bye bye.